Hello, welcome to the first SAT Maths YouTube video. Who'd have thought I'd be a YouTuber at this stage of my career? Today we're just going to run through the first higher paper that was done in the recent Year 11 mocks. Hopefully my cat isn't going to interrupt me halfway through, but we'll play it by ear. We'll work through question by question. If you've got any other things that you want to ask about, just leave them in the comments. So, to start with, we've got our multiple choice questions. First one, we had two right-angled triangles. It tells us that that's 6 and that's 9, so therefore we can work out the scale factor is multiplied by 1.5. So we do 3 times 1.5 to get to this side here. 3 lots of 1.5 is 4.5. Work out the value of 1.5 squared. Lots of different ways of doing this. We can do 1.5 times 1.5, which is 1.5 times 1.5. Well, 15 squared is 225, so 1.5 squared is 2.25, which is the same as 2 1/4. We could convert them. 1.5 is the same as 3 halves. 3 halves times 3 halves. 3 times 3 is 9. 2 times 2 is 4, and then convert it to 2 1/4 that way as well. Next one, work out the arc length. An arc is just part of the circumference. So we've got a semicircle that is a radius of 4 meters. If the radius is 4 meters, therefore the diameter must be 8 because of the factor of 2. Semicircle is half a circle, so we are going to do circumference is pi times diameter, pi times 8. Semicircle is half that, half of pi times 8 is 4 pi. On to question 4. Circular fraction that is equivalent to 6.375. Again, various ways of doing this. If you divide the numerator by the denominator, you'll get the actual value. So 43 divided by 8, 8 into 43 goes 5 times with 3 left over. 37 divided by 8, 4 times with 5 left over. 63 divided by 8 is 7 times with 7 left over. And then 51 divided by 8 is 6 with 3 left over. The only one where the 8 goes in 6 times is the last one, so the 51 over 8. Write 0.00423 in standard form. So standard form has to be between 1 and 10. It's the first number, then it's times 10 to the power of something. 4.23 divided by 10 cubed gives us the correct number. So therefore, divide by 10 to the 3 is the same as times it by 10 to the minus 3. Because when you've got a negative power, it just means 1 over. Work out 1 times 10 to the 6 divided by 2 times 10 to the 3. Again, a couple of different ways of doing it. It wants to answer an ordinary number, so just always be careful to look at how it wants your answer. Sometimes standard form, sometimes ordinary number. If we convert them to ordinary numbers, 1 times 10 to the 6, well 10 to the 6 is 1 million. 2 times 10 to the 3, 10 to the 3 is 1,000, so that's 2,000. So I've got to do 1 million divided by 2,000. It's the same as 1,000 divided by 2, which is 500. Or we could leave it as standard form to start with. So 1 divided by 2 is 0.5. 10 to the 6 divided by 10 to the 3 is 10 to the 3 because of indices laws. 6 take away 3 is 3. So we've got 0.5 times 10 to the 3, which again is a half times 1,000, which is 500. So how many we've got there? 1, 2, 3, 4, 5, 6, 7 marks. Yeah, it says that on our first page. On to the next one. Now, this question, when we were marking the papers, was one of the worst done questions across all of the papers, higher and foundation. I think it's because the way the probability tree is put together. Normally, you only have 2 branches and then there's the same amount of branches up there, etc. It's because this one stops and has 3 options, it just really threw people. So if we break down what the question's actually asking us, she's playing a game with an ordinary fair dice, so we know that equal chance of landing on each side. 6 sides on a dice. 1, she wins, so the probability of rolling a 1 on a standard fair dice, 1 out of 6. If she rolls 2 or 3, she loses. Probability of 2 or 3 was 2 sides out of the 6 sides, so 2 out of 6 or 1/3. And if she rolls 4, 5, 6, she rolls again. So that's 3 out of 6 or a half, and it already tells us that down there. When she has to roll again, if she rolls an odd number, she wins. If she rolls an even number, she loses. So probability of an odd on a dice, 1/2. Probability of even on a dice, 1/2. So the first bit, to get our first 2 marks, we just need to fill in the tree diagram. So the first roll, chance of rolling a 1, well, we've already said is going to be 1 out of 6. Probability of rolling a 2 or a 3, 2 chance out of 6, or 1/3. And then over here, probability of rolling an odd on a dice, when she wins, that's 3 out of 6 or a half. Even, she loses, again 3 out of 6, half. Branches there have to add up to 1, because you're either going to get an odd or an even. Same with these 3 here, they have to add up to 1. 1/6 plus 2/6 plus 1/2 or 3/6, again adds up to 1, because you've got to get a 1, a 2 or a 3 or a 4, 5, 6. This bit here, then a lot of people didn't quite understand what it was actually asking. Is Anna more likely to win or lose? You must, any word on bold, always going to be important. You must work out the probability that she wins. So we're going to do that. So the ways to win. 1, she can just roll a 1. So there's 1/6 chance of that happening. We've got that over here. So that's the first way she can win. The second way that she can win, she rolls a 4, 5, 6, then rolls an odd. So the chance of me rolling a 4, 5, 6 is a half chance. Then the probability of me rolling an odd is also a half chance. We're going to multiply those together. So 1/2 times by 1/2 equals 1/4, because 1 times 1 is 1, 2 times 2 is 4. So the chances of winning are either a 1/6 or a 1/4. So if we add those two together, 1/6 plus 1/4, I'm going to convert these into equivalent fractions that I can actually add together with the same denominator. So 1/6 doubles to 2/12, 1/4 multiplied by 3 gives me 3/12, 2/12 plus 3/12 gives me 5/12 in total. At this point, that's enough for you to work out that there's more chance of losing, because if there's 5 out of 12 chances that she's going to win, there must be 7 out of 12 chances she can lose, because she either will win or lose. But just for completeness sake, ways to lose: roll a 2 or a 3, so 1/3, roll a 4, 5, 6, then roll an even. Again, that's going to give me a half times a half is 1/4. So the probability to lose is going to be a 1/3 plus a 1/12. Again, convert them into equivalent fractions. So that's 4/12 plus 3/12, which is 7/12. 7/12 is greater than 5/12, so therefore there's more chance of losing. Right, question 7. A lot of people got 20 for this one, especially the people that did it via the foundation paper, because this was a crossover question. 5 friends arrive at a party. Their arrival increases the number of people at the party by 25%. So 5 friends is 25%. In total, how many people are now at the party? And that word "now" is important. So there's, again, plenty of different ways of doing this. I've called the original number of people at the party X, and we've got 5 have arrived, and that's now 1.25 times by X. 100 plus 25 is 125%, which is a multiplier of times by 1.25. We can then solve that equation. X plus 5 equals 1.25x. Take X off both sides, you get 5 equals a quarter of X. If a quarter of something is 5, 5 times by 4 gives me 20. So there were 20 people originally at the party, plus the extra 5 gives me 25. The other way to do it is to say 25% equals 5, therefore 100%, again we have to multiply by 4 there, times that by 4, so we get 100% of the people that start with 20, plus the 5 gives us 25. Work out the value of this series of 3 to the power of. Just got to remember our indices laws. So 3 to the 6 divided by 3 to the 5. We're going to subtract the powers because they cancel from top and bottom. So 3 to the 6 divided by 3 to the 5 is 6, take away 5, 3 to the 1. Same for the second bracket. We've got 3 to the 4 divided by 3 squared. 4 take away 2 is 2, so we've got 3 squared. 3 to the 1 multiplied by 3 to the 2. So in total, if we wrote that out, that's 3 times by 3 times by 3. That's 3 squared, that's 3 on its own. So in total we've got 3 to the power of 3. and 3 to the power 3 is equal to 27, because 3 times 3 is 9, times that by 3 gives you 27. Just make sure when it says give the value of, we want the value. A number of people lost a mark because they just put 3 to the power 3 as the final answer there. Give the value 27. Right, question 9. Nice question. Shaded semicircle. So I'll just shade in there a little bit just to help you see it a bit better. Is inside a circle as shown. It gives us the radius there, it gives us the diameter there. How many times bigger is the unshaded area than the shaded area? Again, important word there, area. Big area on this type of question is normally people doing circumference instead of doing area. So I wrote down straight away, area of a circle equals pi r squared. Pi times the radius times the radius. I'm going to break it down. First bit, large circle area. So pi r squared, so that's pi times 6 squared. So that's 36 pi, because it's non-calculator paper. The semicircle tells us the diameter's 4, so therefore the radius must be equal to 2. Semicircle, so it's going to be half of a full circle, so pi r squared would be the full circle divided by 2. Pi times 2 squared, so that's 4 pi, divided by 2, that gives me 2 pi. So I know the full area is going to be 36 pi, and then the shaded bit is going to be 2 pi. This is where a number of people then lost a mark. They gave it as 36 divided by 2 gave an answer of 18. However, the unshaded area isn't actually 36 pi. It's 36 pi take away the 2 pi of the semicircle. So 36 pi take away 2 pi is 34 pi. 34 pi divided by 2 pi then gives us 17 times bigger. Hope everyone's having a interesting time at home, staying safe. It's lucky that we live in an age where we do have lots of things around the house, hopefully, to keep us entertained. Question 10. This time we've got a formula, number of items. It's made in 1 hour by machine is given by number of items equals 60 divided by the time. Time is the t is the time in minutes the machine takes to make 1 item. The value of t changes for different types of item. On the grid below, draw the graph of n equals 60 over t for the values of t from 1 to 4. So we've got to work out each point. So first of all, at t equals 1, 60 divided by 1 is 60, so we put that point there. At t equals 2, 60 divided by 2 is 30. 60 divided by 3 is 20, and 60 divided by 4 is 15. We make sure we do a nice smooth curve. I've done it in pen just so it shows up a little bit better. Obviously you should be doing it in pencil. When you're doing a smooth curve, try not to go like that. It's called feathering and you're going to lose a mark for it. Nice smooth curve in pencil. If it goes wrong, rub it out, try it again. But I said if you've got it like that and there's lots of lines going on, you're going to drop a mark. The machine takes 3 minutes 30 to make 1 item. Use your graph to estimate the value of n. So we're going to draw a line straight up for 3.5 minutes until we hit our line that we've done, then go straight across, and that gives us approximately 17 minutes. Ed and Faye share £270 in the ratio 2 to 7. Faye gives Ed some of his money. Faye now has the same amount as Ed. How much does Ed give Faye? Technically that was a misprint in the exam, it should have been Faye give Ed, but thankfully most people realised that when they did the question. So to start with, we're going to do 270 divided by 2 plus 7. Essentially what you've got 2 parts and you've got 7 parts. So in total there, if you imagine those as piles of money, that's going to be 9 piles of money. So 2 plus 7 is 9, so 270 divided by 9 gives you 30. So each pile of money is going to be worth 30 quid. So therefore Ed gets 2 of those piles, so he gets 60 quid. Faye gets 7 of those piles. 7 times 30, 210. If they want the same amount, well, they've got to share the money equally. So 270 divided by 2 is £135 each. So either you can think, right, 135 take away the 60, which is 75, or 210 take away the 135, which is 75. Either way, they've got to exchange 75. The other way to think about it, the difference between 210 to 60 is 150, so halfway between the two is going to be 75. Next one. The next term of a sequence is made by adding the previous two terms. So this is a Fibonacci sequence. Fibonacci, very, very important Italian mathematician. So this is the correct answer here, just to prove why these don't work. -3 plus 5 gives me 2, so that one doesn't work. 0 add -3 gives you -3, so that bit works, but then -3 add another -3 give you -6. -1 add -1 is -2. -1 add -2 is -3, but then -2 add -3 actually is -5, not 1. So it's the only possible one that does work. As I say, just proving it here. -9 add 2 back on gives you -7. 2 add -7 is -5, and then -7 add -5 gives me -12. How many marks are we up to now? So that's 7, 13, 22. So we're up to 30 marks now. So that's 3/8 of the paper done already. 3/8 of paper, 37.5. So that's guaranteed you a 5 if you've got everything right up to that point. Next question. Triangular cross section of a prism. So the important word there, prism. A prism is where you've got a 2D shape and you've stretched it. So no matter where you cut the cross section, it will always form the same shape. So like a Toblerone packet is a triangular prism. So to work out the prism volume, it's always the end area, so in this case that area there, times by the stretch times by the length of that dimension there. So in this case the end area is a triangle, so it would be half times base times height, because every triangle is always half of the rectangle around it. So that's half times x, because dimensions are x there, so it's a nice isosceles right angle triangle. So that's half x squared. It says use approximations, so really, really important there, approximation. So we're not going to try and use the 5.2, we're not going to try and use the 41 as the volume. Must show you working, so if you just manage to guess it, you've got to make sure you show it fully. So my approximations, the length of 5.2, when we're doing approximations, estimations, you end up rounding to one significant figure. So first significant figure there would give me just 5. 41 would round to 40. So I know half x squared, the end area, times by the stretch 5 gives me 40. So I'm going to divide both sides by 5. 40 divided by 5 is 8. So I know half x squared equals 8. Half x squared can also be wrote as x squared divided by 2, because that's all half means. So therefore multiply by 2, you get x squared equals 16. Something squared equals 16, therefore x equals the square root of 16, which technically is 4 or -4, but you're not going to get a length of -4, so therefore your answer must be 4. Next one, quadrilateral. As soon as you see a quadrilateral, it's asking about angles. Important fact to remember, quadrilateral angles have a total of 360 degrees. It gives us some nice ratio parts for this. So it tells us this angle here is 90 degrees. It also then tells us that the ratio between A and B is 6 to 5. So if 6 parts is going to be worth 90 degrees, 90 divided by 6, that gives us 1 part is 15. So then 15 times by 5 gives me 75. So I know B is going to be 75 degrees. 360, take away 90, take away 75, so take away the two angles that we know. So that's 360, take away the A and the B. That gives me 195 degrees, which is what X and Y must add up to. It also then tells me X and Y are in a ratio of 5 to 8. 5 plus 8, so we're going to do very similar to what we've done in a previous question. 5 plus 8 is 13. 195 divided by 13 is 15. Lots of different ways of doing that. 10 lots is going to be 130, leaves you 65, and then 13 is going to 65, so 15 lots in total. So therefore X is going to be 5 lots of the 15, which is 75. So if I know that's 75 and that's 75, it just says show that, b equals x. We've proved both of them are 75, therefore we've completed the question. Zoomed out a little bit then. Right, we're up to the staples. If we're up to the staples, it means we're about obviously halfway through the paper, so we're up to probably about a 6 by now. Nothing in there that is beyond the vast majority of people who are on higher. 15. Information about the test marks of 120 students. So we've got the mark between 0 and 10, 10, 20, etc., and the frequency, the number of people. Complete the cumulative frequencies. That's the important bit here. It's quite a nice question for you, really, because it actually even gives you the boundaries. Sometimes it won't give you that. You'll just have to create the table yourself, and you've got to try and remember that it's the upper bound that you plot with the cumulative frequency. But in this case, it's actually quite nice, and it actually tells you anyway. So cumulative frequency, it even gives you the first couple. So if you can't remember what it is, you can actually just work out that you must have done 20 and then 20 plus 28, etc. Cumulative just means up to a certain point. So everyone that's less than 10, 20 of them. Everyone that's less than 20 is those two there. Everyone that's less than 30 is those three there. So we just keep adding on the next number. If you don't get to 120 at the end, you know you've gone wrong, because it did tell you there was 120 students there. We're then going to draw our cumulative frequency graph. So I said, if it doesn't give it you like this, just remember cumulative frequency, you have to plot the upper bound of the group. There are others like frequency polygon, for example, where you plot the midpoint, but in this case the upper bound. So 10 is going to get plotted against 20, 20 against 48, etc, etc. We're then going to again draw a nice smooth curve through them. Generally that's going to be the shape of your cumulative frequency graphs, like an elongated S. It then, as ever, has a follow-up question based on that. So students who score 15 marks or fewer, so less than, take another test. Use your graph to estimate how many students take another test. So we're going to draw our ruled line. So we're going to go up from 15 till we hit our graph, and then we're going to go across. So for my graph, it's approximately 30. Obviously there'd be a couple either way, and it would be looking at where it is on your particular graph. Question 16. Simplify fully. If you've got an algebraic fraction, which we have here, and it's saying simplify, the vast majority of the time it's going to be involved in factorising. Not a nice question, and it will catch a lot of people out. If we factorise this, 4x minus 8x squared, highest common factor there is 4x, that leaves us 1 minus 2x. Just be careful, some people will put just the minus 2x. You've got to remember that 4 divided by 4 gives you 1, so we do need the 1 in there. The bottom bit, the denominator, 12x minus 6, they've got 6 in common. Always take the highest common factor. I know they've got 2 in common, 3, but 6 is the highest common factor. So 6 into 12x, 6 into 6 gives you 2x minus 1. This then threw a number of people. So we've got 1 minus 2x as the brackets of the first bit, and 2x minus 1 as brackets for the second bit. They're not quite the same, so I can't cancel them out as simply as that. What I can do though, if I multiply everything by minus 1 here, so 4x times minus 1 is minus 4x, minus 1 times by 1 is minus 1, and then minus 2x times minus 1 is plus 2x. Just flip that around to make it easier. So I've got minus 4x, 2x, minus 1. We then have got exactly the same bracket on top and bottom. So I can now simplify that by dividing 2x minus 1 divided by 2x minus 1. Cancels out, so I'm left with minus 4x over 6. Again, at this point, a number of people got that answer there. Simplify fully. We've got to take it down as far as we can. 4 and 6 have 2 in common, so that gives us 2/3. So minus 2/3 x minus 2x over 3, however you want to write it. But we've got to try and make sure we don't leave it as 4 and 6. Question 17. Again, a number of people went wrong on this one, mainly because they totally forgot what the word product means. Product means multiplication. So the multiplication of half of a number, so half y, and 3 more than the number, so y add 3, is the same as equal to the square of the number, y squared. So it tells us that Toby uses y to represent the number. So it's going to look like this: half y, the product, multiply y plus 3 equals y squared. That's enough to get marks down, just a little bit simpler. So take out the multiplication symbol, half y brackets y plus 3 equals y squared. You could expand the bracket out if you wanted to there, but there's no particular need to. Toby forms another equation, x equals 9 over 8x. He wants to work out the values of x. Here is his working. So he starts there. He takes the 8x to the other side by multiplying by 8x. That's absolutely fine. His error, because that was the whole point of the question, is this point here. He's square rooted to get rid of the square on the x. So he square rooted the 9, fine, that's 3. He's not then square rooted the 8, so it should be the square root of 8x equals 3. So either you can say he hasn't square rooted the x, or probably how I would have done it would have been to take the 8 to the other side first. So x squared equals 9 over 8, so x equals the square root of 9/8. Here is an identity. So an identity means it is always true. It doesn't matter what numbers we put in there, it is always going to be true. So use the identity to work out the value of 93 squared minus 7 squared. You must show your working. Again, a lot of people made this really hard for themselves. They worked out 93 times 93, they worked out 7 times 7, and they took it away that way. We can just put our numbers in here. We can assume that's x, that's y, so x plus y, x minus y. So 93 squared minus 7 squared is 93 plus 7, 93 takes 7. So that gives me 100, that gives me 86, 100 times 86, 8,600. Next bit, factorise 64a squared minus 25b squared. So a difference of two squares question, so it's going to go into double brackets where both the first terms and both the second term are the same, just one's addition, one's subtraction. To do that we take the square root of everything, so square root of 64 is 8, square root of a squared is a, square root of 25 is 5, square root of b squared is b. So it's 8a plus 5b, 8a minus 5b. If you've got time at the end of the exam, expand that bracket back and you will find that it would give you that answer. Question 19, just a random multiple choice question thrown in again. Circle the fraction that is equivalent to 0.4 recurring. So that little dot means recurring, so 0.444 on and on forever and ever. It's probably useful to know that anything with just one digit recurring straight away is something over 9. So 0.4 recurring is 4/9. Just like if I had 0.2 recurring, that would be 2 over 9, etc., etc. There's various ways to work it out. You could just do 4 divided by 10, which is 0.4, doesn't work. 44 divided by 100 is 0.44, again doesn't work. 4 over 99 gives you 0.04, etc. It doesn't work. If you try to do 4 divided by 9, as bus stop or ever like to divide, put a couple of zeros on there. 9's into 4 doesn't go, so we carry over. 9's into 40, well that obviously goes 4 times because 4 9's 36, you've still got 4 left over. 9's into 40 goes 4 left over. 9's into 40 goes 4 left over, etc., etc. So that's why that one is 0.4 recurring. There is algebraic ways of doing this as well, so you could call x is equal to 0.4 recurring, so therefore 10x is going to be 4.4 recurring because we're just going to multiply everything by 10. Ending the same, so I'm going to do this, subtract that. 10x take away x is 9x. 4.4 recurring take away 0.4 recurring just gives me 4, and then rearrange it, so x equals 4 over 9 by dividing everything by 9 there. What time are we on? 30 minutes already. So it takes quite a long time to do this, doesn't it? I hope I've not bored you too much yet. It's very weird trying to talk through an exam paper when you don't have a class. Teachers are used to being in front of people. You kind of work off their reactions, answer questions, etc. It's weird, I don't think I'm cut out to be a YouTube superstar, but needs must and all that. Question 20. A, B and C are points on a circle, so we've got a triangle within a circle. CD is a tangent, so we've got a tangent there. Assume that triangle ABC is isosceles with AC equals BC, so AC equals BC, so I'm going to put lines on there straight away just to prove that it is the same. We've got to try and prove that this line AB is parallel to DC. So I'm going to call this angle X to start with. It doesn't really matter what you call it, but I'm just going to base all my assumptions on this angle here. Alternate segment theory, so that's when you've got a tangent that comes along and matches with a triangle within the circle. That states that this angle here is the same as the opposite corner in the triangle, and if I continued it, this angle here would be that angle there. So therefore, if that's X, that one is X. We know that it's an isosceles triangle, so therefore base angles, so if those two sides are the same, those angles are going to be the same there. So if that's X, that must be X as well. We then also have got an X there and an X there. Because these two match, due to alternate angles are equal in parallel lines, because they match, this must be my alternate angle, the Z shape. Obviously we don't write Z shape, we say alternate angles. So because those two match, therefore these two lines must be parallel lines. It then says, in fact, it's actually equilateral. Tick the two boxes of the statements that must be correct. So here's just another little small version. So I've got 60, 60, 60, because equilateral triangles all have 60 degrees. Well, because of what we've already said, if that's 60, that must be 60. We've proved that. So it's definitely parallel. That's fine. AC bisects. Bisects just means cuts in half, exactly like when we talked about perpendicular bisectors in the past. So bisects angle BCD. So angle BCD is that angle there. Because they are both 60, so the whole angle's 120, that line there does bisect it, so it's fine. The one that's wrong, AC, this line here, bisects angle BAD. BAD is this angle here. We know nothing about that angle there. We can't work it out in any way yet. So therefore, the third statement is false, so we tick those two. Just be careful, there's a number of people that, despite it saying tick the two boxes, only just ticked one. Please read the question. 21. Solve the simultaneous equations 2x plus 3y equals 5p and y equals 2x plus p. There's a couple of different ways of doing this. You can either substitute or you can rearrange. So this is the substitution method here. We say that 2x plus 3y equals 5p and y equals 2x plus p. So what I'm going to do, I'm going to swap this y here for what I know y actually equals. So 2x plus 3y becomes 2x plus 3, 2x plus p. Multiply that bracket out, we get 6x plus 3p. Collect like terms, so 2x plus 6x is 8x plus 3p. Take 3p off both sides, so you get 8x equals 2p. Therefore, divide everything by 8. 2 divided by 8 is 1/4, so x equals 1/4 p. Once we know what x is equal to, we can substitute back into one of our originals. So y equals 2x plus p, so that becomes 2 1/4 p plus p. 2 lots of a quarter is a half, so I've got half p plus another p, which gives me 1.5p. You could have done it differently. You could have rearranged this one to give you y minus 2x equals p, and then you've got 3y plus 2x equals 5p. So these are nearly the same. If they're nearly the same, we're going to add them together. So 3y plus y is 4y. 2x plus minus 2x cancels out, and then 5p plus p gives me 6p. So therefore y equals 6p divided by 4, 6 over 4p. 6 over 4 is the same as 1.5p. And then again, we just substitute back in that to get the other way. Do the zoom on the camera. Okay, our next one, vector question, everyone's favourite. First part, nice and easy. It's one that everyone always nails. The second part sometimes gets people. It's not the hardest second part ever, but it's not totally straightforward. So we've got our triangle here, and it tells us some vectors on it. So first of all, show that. Show that means we've got to prove y. So CD equals 6a plus 4.5b. So to get from C to D, that's the vector y. So CD, we can't go along this line because we don't know anything about it. So we have to go from C to A first, and then from A to D. C to A, because it's 3b that way, it's going to be minus 3b going in the opposite direction. AD we do know, and we're going in the right direction, so it's just 6a plus 7.5b. If we then simplify that, we've got 7.5b take away 3b, which is 4.5b. So we've got 6a plus 4.5b, which is what we want to try and prove. Part B tells us that BCD, so this line here, is a straight line. So therefore, I know that whatever the vector is here and the vector is here, they're going to be multiples of each other. So first of all, I know BC, this line here, is going to be KA, to get from B to A, and then add 3B, so it's KA plus 3B. So BC times by something, because I said it's got to be, this has got to be a multiple of this, or vice versa, gives me CD. So something times KA plus 3B gives us 6a plus 4.5b. Well, the b's has gone from 3b to 4.5b. Well, to get from 3 to 4.5, you multiply by 1.5. So therefore the k is also going to be multiplied by 1.5. So you can say 1.5k is equal to 6. I'm then going to divide by 1.5, so 1.5, 3, 4.5, 6. So k must have stood for 4, because 4 times 1.5 gives me the 6. 23, again, wasn't brilliantly answered. It's understanding how to write things in different base units. So we've got 16 to the power 4. 16 is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can write 16 as 2 to the power 4. The clue is the fact that it wants its answer in 2 to the something. So straight away you've got to write everything in terms of what it is as 2 to the power of. So 16 is 2 to the 4, so that becomes 2 to the 4 to the 4. 2 to the 4 to the 4 is 2 to the 4 times 2 to the 4 times 2 to the 4 times 2 to the 4. So that's 4, 8, 12, 16. So 2 to the 4 to the 4, 16. We'll just do 4 times 4. 8 to the 2/3, well, splitting that fraction up, that's 8 to the 3rd squared, because 1/3 times by 2 gives you 2/3. The third is a cube root. Again, that's just something you need to learn. So 1/3 power is the cube root. The cube root of 8 is 2, because 2 times 2 times 2 gives you 8. So then you've got 2 squared, which is 4, but we're just going to leave it in this format here. So now we can finally simplify everything. So we've got 2 to the power of 16, divide by 2 squared, so that's going to be 2 to the 16, take away 2, so that's 2 to the power of 14. Question 24. Again, it's only a 1 mark, a little multiple choice question. It's all about knowing what the shape of your sine graph looks like. So sine x plus 90, well, if x is 0, that's just 0 plus 90, so we're looking for the value of sine 90. Either you learn it, or you learn what the shape of the graph looks like. That is the shape of a sine wave. Starts from 0, goes up to 1, back to 0, down to -1, then back to 0 at 360, repeats every 360, 1 and -1 the limits. At 90, the value of sine is 1. Right, on to our last couple of pages now. So we've got a few more difficult questions that are really going to sort out the people who are going to achieve their 8s and 9s. P for 8 is a point on a circle, centre 0. Tangent at P intersects the axes at points A and B. So we've got a tangent to a circle, it's going to hit there, and it's going to hit here. First of all, show that. So it's another one of these show that questions. So we can't just assume anything, we've got to actually be able to prove it. So we have Radius and tangent make 90-degree angle. That's how you always work out a lot of these circle equation tangent type questions. They make 90-degree angle, they're perpendicular. So I know that whatever the radius is, that's going to make 90 degrees there with the tangent. That then leads us into knowing that a gradient of a line times by the gradient of the perpendicular always gives you -1. So our radius, it is going from 0, 0, the centre, that's why it tells it is the centre there, to 4, 8. Gradient of a line, change in y divided by change in x. That's all gradient is, dy dx, delta y, delta x, however you want to put it. So we've got change in y, 0 to 8, that's gone up by 8, 0 to 4, gone up by 4, 8 divided by 4 is 2. So therefore, using what we've just said, 2 times by something has to give me -1, therefore the something, the gradient of the perpendicular, would be -1 divided by 2, which is -1/2. Essentially what you're doing is the negative reciprocal. So reciprocal means you take a fraction and you flip over the denominator and numerator. So we've got negative because it's positive, and then 2 over 1, because that's all 2 is, it's 2 wholes, becomes 1 over 2, and that's what we wanted to try and get to. The harder part of this now, it's saying work out the length AB, so I need the length of the tangent between those 2 points. First thing we need to do, we need to work out what the equation of our tangent is. So we've already got the gradient is -1/2, so even if you couldn't prove it over here, you know that it's going to be y equals -1/2 x plus something plus the constant, because it's straight lines, therefore must be y equals mx plus c. Using the point that we know it goes through, this point 4, 8, I can substitute in, so y equals 8 and x equals 4, so I've got -1/2 times 4 plus something gives me 8. -1/2 4 is -2. To get from -2 to 8 you add on 10, or do the reverse there, so opposite of subtract 2 is add 2, 8 add 2 is 10. So I know that the gradient is -1/2, I know the constant is 10, so the equation of my tangent is y equals -1/2 x add 10. I then know things about these points here. So this point here, it is on the x-axis, so therefore the y value is going to be 0, so it's something 0. Inversely here, this is on the y-axis, so the x value is going to be 0, because that's all your x-axis in. X-axis as line is y equals 0, and y-axis is x equals 0. So we're going to substitute in, so point A, y equals 0, so 0 equals -1/2 x add 10. So therefore take the whole of that to the side, half x equals 10, half of something is 10, x must be 20. So I know this point here is 20, 0. Over here, point B, x equals 0, so I've got y equals -1/2 times 0 plus 10, well -1/2 of 0 is still just 0, 0 plus 10 is 10, so I know this point here is 0, 10. I can now use Pythagoras to work out the length of this line. So this little kind of version of that diagram there, that's 0, that's 10. So that length of that right angle triangle is 10. That length of the right angle triangle is 20. Pythagoras states that the squares on the shorter sides give me the same as the square on the long side of the hypotenuse. So 10 squared plus 20 squared gives me this length squared, the c squared. 10 squared is 100, 20 squared 400. Add them together we get 500. 500 equals c squared, therefore c equals the square root of 500. Surd rules now, so square root of 500 is the same as the square root of 100 times the square root of 5. Square root of 100 is 10, so we get 10 root 5. A lot of different processes in there. You've got all your stuff to do with circle equations, you've got your stuff to do with perpendicular, you've got y equals mx plus c in there, you've got substitution, you've got Pythagoras, you've got surd laws. It's a lovely, lovely question. Right, on to the last page. Turning point of the graph, y equals x plus a squared plus b has x coordinate 4. It tells you 3, 6 is another point on the graph. Work out the y coordinate of the turning point. So turning point of the graph is where the gradient is 0. So there are multiple ways of this, but we're looking for this point here. So it tells me it's 4. We've got to try and work out the y point. Now, from completing the square, which this is, because that's a completed square version, you get your x coordinate by doing the opposite of whatever number is in there. So if I've got x plus a and it gave me a coordinate of 4, I know that this number here must be minus 4, because you have to basically make that bracket 0. So therefore x minus 4 must be the bracket, because when I put 4 in it, 4 take away 4 gives me 0. So we can put that in. So y equals x minus 4 all squared plus 4. So that gives me the x coordinate. I'm then going to use this point. So it tells me that when x is 3, y is 6. So I'm going to substitute in y is 6, 3 take away 4 squared plus the something, that's what we're looking for. 3 take away 4 is negative 1. Negative 1 squared minus 1 times minus 1 is just 1. So we've got 6 equals 1 add b. Well, take 1 off both sides. B must stand for 5. So therefore my finished version is y equals x minus 4 all squared plus 5. Just like in y equals mx plus c, the y-intercept is that bit there, it's the constant on the end. So answer, where is the y coordinate at the turning point? It's 5. Right, last question. Hope you're still with me. Angle x is acute. It's important to state that for various reasons, but it doesn't really matter in this case too much. Cos x equals sine 30 times tan 60. Work out the size of angle x. You must show your working. There's various ways of doing it, but you could use the triangle to help you. You could use this table down here. You could just learn them off by heart. Sine 30 is equal to 1/2. Tan 60, well, tan is just sine over cos, so sine 60 divided by cos 60. Sine 60 is root 3 over 2. Cos 60 is 1/2. Root 3 over 2 divided by 1/2. So that's root 3 over 2 times 2 over 1. 2's cancel out, so you got root 3. So tan 60 equals root 3. Therefore, cos x equals 1/2, the sine 30, multiplied by root 3. So that's root 3 over 2, and root 3 over 2 is going to give you 30 degrees. As I said, there's a table there. If you've done it that way, there's the triangle, but lots of different ways of doing it. Right, so that's the run through of the whole of paper 1. Intending over the next few days to get all the other papers done and then start working way through other practice papers. If you've got any other questions, please let me know, either via show my homework, via the email address, or just leaving comments here. I'm going to put a link to this via the Instagram page as well. If you've managed to watch all that and it's made sense, well done, thanks for sticking with it. We're living in really interesting times at the moment, so we're going to try and make do as much as we can. Just remember, it's all going to be over. Everything will turn out okay, but we need to make sure our education is still going ahead. We can't afford just to do nothing and to go backwards. You know, your futures will still be really, really rosy as long as you're not just taking the opportunity to slack off. I'm sure you're not. You're watching this video, so I'm sure you're not. Alright, thank you very much. I will talk to you again soon. Bye.